Okay, so we have seen a lot of megatrends, and we're going to come back to one megatrend we briefly touched this morning, so the megatrend of big analog data. And to cover this, we have somebody here we would like to talk about big analog data in more detail, because he's like one of the masterminds behind that. So please welcome to the stage from Hewlett-Packard, Dr. Tom Bradicich, Vice President of Server Engineering.
Thank you, Daniel. Thank you. Boy, is it great to be here. I don't know if you know this, but there was a time where I was an NI employee. And working for National Instruments has afforded me the opportunity to understand some of the grand challenges that Dave and Daniel and the guests that are here today have spoken about. But it's quite exciting to blend the world of engineering and science with the IT world, the information technology world, in which I reside now. And it's actually amazing I was invited back, I think, to speak here. Nothing like this ever happened with any of my former girlfriends. However, I am invited back to be here, and it's a thrill for me, personally, as well as professionally. In the little time we have left, I'll take you through managing big data in the analog world, or what is sometimes called big analog data. Now, who has heard of big data? Just big data in general. Well, good. If you haven't, you need to get out more, because there is not a company in the world that doesn't have a big data initiative, a vision, or something like that, because of its profound influence on the way business is done. Now, the big data that we're talking about here in the context of National Instruments comes, I think you would agree with me, primarily from the world of the physical, the world of analog phenomenon, which you've heard many, motion, sound, etc. So let me take you through this, but let me step back. And a colleague of mine, the late Jim Gray, a scientist at Microsoft, wrote a book called The Fourth Paradigm, and you see on the slide behind me that he just tracked the history of some science discovery and innovation, and very quickly concluded that there was experimental science, theoretical science. Then the computational sciences appeared, of course, at the middle of the 1900s, when computers were created and calculating machines that could do significantly more than the mechanical devices. And then he predicted several years ago, that there would be a data-intensive era, which we are in right now. He didn't call it big data. It was before the term big data became vogue. But he predicted that there would be unifying theories around data and analytics, and that data would be captured more and more by instruments. And that's a familiar thing to, of course, National Instruments. And, of course, National Instruments has been doing this in the 70s, but it's really, I think you'd agree with me, graduating or elevating to a new level, this data collection and the sensors and the acquisition in the world that National Instruments resides, especially as we have things like the fourth industrial revolution, Industry 4.0, when we have things like the Internet of Things, the industrial Internet of Things, the Internet of Everything, and all these vogue marketectures. Marketecture is a blend of two things, right? Marketing and architectures, and as we have this more and more data generated by not people, but by machines and events, etc. These popular marketectures have really dominated the landscape of reading, of technology reading today. And you can see them behind me. Intel leads with intelligent systems. IBM leads with the smarter planet. Then there's the programmable world, cyber-physical systems, that NI is a leader in. And NI has big analog data solutions. You'll notice the trademark, one of the last things I contributed to National Instruments before leaving for HP was helping the marketing teams trademark and get around the idea of big analog data solutions as well. Let me characterize big data for you. I think if you know anything about it, it's all about the 4 V's. And the 4 V's are their variety, volume, velocity, value, and big data is characterized by one or more of these, not all of them at the same time. And I would like to contribute to the body of knowledge by adding a 5th V called visibility, and the ability to see data and gain the insight from the data from anywhere in the globe and then even in outer space. In other words, think about this, annihilate the location and time constraints when accessing data. When the National Instruments Company started, data was acquired, analyzed, and presented, and conclusions were drawn literally in one room, literally perhaps on a bench. That's how the company started. Today, data is collected in, for example, out in a cornfield in Ohio in the United States and needs to be analyzed by a data scientist in Brazil. And then in Europe, action might be taken to control perhaps the pesticide that's being used, the fertilizer that's being used, or even the tractor, the off-road vehicle that's being used in that data collection environment. So the geographical dispersion is of keen interest to me personally now, because at HP we can create information technology to bridge those gaps and annihilate both time and place. Let me also continue with the sources of big data. This is a gross trifurcation, 3 parts of big data. There's traditional big data, which is stock ticks and HR and sales events, and that's very common. There's the new and emerging data, which I find fascinating, I'm sure you do, called social data. Everyone here, I believe, is attached to a social network, and therefore you can connect with me on LinkedIn if you'd like. There's Facebook, there are others in Europe and Asia as well. And data scientists say that if they can monitor and analyze all of your posts, all of your comments, all of your email, all of your tweets, they can predict what you're going to do next, which is particularly easy if you tweet what you're going to do next. I can just imagine a guy says, I'm going to go to McDonald's for a hamburger, tweet. The data scientist says, this guy's going to eat. That'll be 120 euros for that insight, right? So when it's not as intuitive as that, then prognosticating and predicting things, like people's behavior, particularly consumer behavior, what will they buy next? Or political behavior, who will they vote for? Who's going to win? What do I have to say to win the votes? Or in this case that we're talking about on this stage, scientific insights, which come from the world of engineering science, or things, or the analog world, right? Now, there's 3 types of insights that I look at the world. There's business insight, which is, oh, who's buying what and how much inventory, do I need? And that's the famous beer and diapers story. Does anyone know the beer and diapers story with big data? Then I will tell you, most of you shook your head. No, what's the relationship? Well, there was a retailer who sold a lot of things, including beer and diapers, and noticed through data analytics, very rudimentary at the time, this is an old story, very rudimentary data analytics, that when beer was sold and diapers were sold, there's a correlation. So every time there was a diaper, seems to be beer being sold, and that was an odd correlation. So the result of that information gave business insight to the owner of the store, right? The insight is there's a correlation. Well, what do you do with that information? Well, he discovered after analyzing that on Friday afternoons, this would happen on Friday afternoons, when the area had a lot of young families, the wife with the babies at home would call the husband and say, please stop by and get diapers. And if you've ever been a parent, you know you run out quickly. Please. So he goes to the store to get diapers, and it's the weekend, so what does he pick up? Beer. Now, what do you do with that information? Well, first of all, business-wise, you never put one or the other on sale because you'll lose money, right? What else would you do? Think about it. You would have a competitive advantage by putting them physically together. So the husband says, oh, I'm going to that store because I just walked to one aisle and there's beer and there's diapers together and I picked them up, right? So that's business insight. The second type of insight is very common to you, called scientific insight. We run these streams of particles around, we collide them, and we say, there's a Higgs boson. And I think National Instruments is credited, am I right, David, for discovering the Higgs boson? Oh, you just helped, okay. Yes, of course, the wonderful mutual customer of both, HP and NNI, CERN, did that, and that's scientific insight. And then engineering insight, for example, what you see right here, Insight CM, being able to discover engineering issues. Well, when will that turbine fail so I can prevent a blackout? That prognostication is very, very key. So big analog data is, as you know very obviously, if you look at the slide, which looks like the American candy Skittles, I don't know if you know that, behind me, all these different phenomena happening, and it's derived from the physical world and digitized. It is everywhere, and it leads me to assert that big analog data is the oldest, fastest, and biggest, listen, biggest of all other big data combined. Now, why would I make an assertion like that? Well, let's start with the oldest. If you subscribe to a theory of origins called the Big Bang, I would assert that was an analog event. There's nothing there to measure it, but I would assert, and I think you'd agree with me, there might have been light and magnetism and motion, perhaps, things like that. and of course sound if it could have been measured, hence the bang. If you subscribe to a creation theory of origins, when God said, "Let there be light," I would argue that is an analog event as well. So this analog data is the oldest in the world. It is the fastest. Just think about video, for example, or think about the electrons vibrating in your body in this room, and then think about the phenomenon of the air conditioning vents vibrating, the light, the sound, your heart beating in this little room here, times this country, this world, this universe. It's the biggest of all big data combined. And here's some big analog data I personally was able to work with while at National Instruments and continue to in my capacity at HP. Smart power grid measurements, 5 terabytes a month. That's nothing, right? Okay, 5 terabytes a month. It's big, but not something that will challenge us in the IT world, and I think even in the data acquisition world. Turbine test, I've been there where they manufacture turbines, and at night they take 10 terabytes a night. Every night they take these 10 terabytes of data, and there's big challenges with how to manage and visualize and derive value and insight, engineering and business insight from the data. Jet engine measurements in flight during test, 20 terabytes in a single hour. And the biggest of all big data I've ever seen, and therefore I I ask you to offer me another bigger one. The biggest I've ever seen is our friends at CERN, who have at times take 40 terabytes in 1 second, and that is absolutely huge. Now I say that because if you want to send me an email if you found any bigger data than that, because when I do keynotes around the world, I say that's the biggest I've ever seen. So therefore, that's the analog world being the biggest of all big data. So how do we attack this? Well, we have a 3-tiered solution. My world, when I was at National Instruments, I was in the middle to the left, tier 1 and 2. And if you look at that, well, they're the NI products that I prominently display. And then I've moved into the world to the right where I put the HP logo of IT systems. That connection is very, very tough to make sometimes. You might say, well, why don't you just hook it up to Ethernet or whatever the case may be? Well, if it's the fastest and the biggest of all data, it has some IT challenges. And to be able to solve them is of great value to end users, great value to customers, because it lowers their integration risk and it lowers their time to value. How fast can I get value out of the servers and workstations I bought? How fast can I get value out of the NI systems that I bought? Now, in the interest of time, I'll go through this quickly, but in the world of IT, real-time starts, real-time, if you talk to an IT guy who hasn't worked at National Instruments, and you say, when is real-time? He would say, well, that's when it comes and enters my server. It goes through the switch and the NIC, the network interface card, into the memory of my server, and that's real-time. We're getting it. Well, if I talk to you or to National Instruments, they'd say, wait a minute, by the time it hits a server in tier 3, it is what? Old. Not real time. It's not new, it's not fresh. It's old because so much has happened from the sensor on. Now this is interesting. The beginning of real time for big analog data solutions is at the sensor. And time to insight is huge. And there's a data insight spectrum here is when I can get insight. Now I want to explain you a trade-off that's in the industry today, and it's mutually exclusive, right? Do you remember the days of the first laptop computers, notebook computers? You had a trade-off of what? Lightweight versus battery power length. The length of the battery, right, would last. That was a trade-off. But when I was at that age, my boss came to me when I was at IBM. I was an IBM fellow and vice president when I left IBM, but in my early days as an engineer, he said, I want you to make a laptop that is lightweight, but the batteries last for days. And I said to myself, that's a mutually exclusive objective. And a mutually exclusive objective is very difficult to solve, right? How do you make everybody happy, right, et cetera, when you have one or the other? Now, listen to this. If you solve a mutually exclusive objective, you can catapult your career. You can make a lot of money, right? So I tell my students, I also serve as an adjunct professor at universities in the United States. I tell them, find a mutually exclusive objective and solve it as well. And here's one here I want to present to you that needs to be solved. And it's all about time to insight. I can get deep insight, but it takes a long time, or I can get very rudimentary insight immediately. See the trade-off? Therefore, how do you get deep, deep, deep insight very quickly, immediately? Now, what's rudimentary insight? For example, if I'm monitoring this turbine generating electricity, I can tell if it exceeds a temperature and it's going to catch on fire. That's a simple compare. Maybe I can do a quick moving average, even a quick fast Fourier transform with one of the fine FPGA technology. But that's rudimentary, I think you'd agree. Contrariwise, if I go all the way to the right on this slide, and I have an entire room full of servers, I can do deep, deep insight, but it could take hours, days, if not. In fact, I know one customer who told me they have stopped collecting data, they stopped data acquisition, unfortunately for NI, and they will now spend the next 10 years analyzing it. Now, that's not immediate time to insight, right? They have enough data for 10 years to do the analytics on as well. So as you go through this, what I call the spectrum of value, and data analytics are executed here, you have a domain of execution that you have a trade-off. It's mutually exclusive. For example, right now with a Rio, a great NI product, we can get very, very quick insight, but I think you'd agree with me, it's limited in its analytics. It's also limited to the amount of data. And what happens when your data is small? Did you learn anything about this in probability and statistics? Your predictions are what? When your data set is small, your predictions are less likely to be accurate. Contrariwise, if your data is big, your predictions are more likely to be accurate. And we're living in a world, remember, of prognostics predictions when we take that measurement. The second domain is putting all that into what I call DAS, or data acquisition and analysis systems, PXI, serial systems, and then it goes forever. It just takes forever to go over that edge into this world of Ethernet, even if it's 10 gig or 40 gig. And it hits something called an edge CPU, or the world I'm in, a workstation or a server, and then it goes back into a cloud. You've heard of that, of course. All these wonderful things. By the way, a cloud is not mysterious. A cloud is simply a data center of servers that nobody is supposed to know where it is. That's the definition of a cloud, in case you want to know what it is. Okay, anyway, so go to the cloud. That's way up there. It takes forever to transmit, and when I say forever, a long time compared to the real time. So these 4 domains of computing, and the trade-off, as you can see on the bottom of the slide, I want you to get that, is the time to insight versus the depth of analytics. So now, the world of deep analytics at the sensor is going to be huge. Think about it. It's absolutely going to be huge, and we can figure out how to do deep analytics. And if you think about it in current terms, you say, oh, I need a lot of memory, a lot of silicon. I need something like the SOM we just saw, but I need it to be bigger. But when I get it bigger, I can't carry it anymore, as Daniel was joking, right, with the serial here. Contrariwise, if you can solve this problem, it will help, obviously, humankind as well as your careers in your company. Let's look at some real-world examples, because if you have a vision and nobody acts on it, you're just a science fiction writer. Contrariwise, if people are acting on it, like the HP company, my team is working with NI engineers on this real-world example of seismic scientific research. It happens to be here in Europe. And in the middle of the tier is the PXI systems, and we're looking at how to connect it to a particular HP server that I'm developing called HP Moonshot. And what's interesting is HP Moonshot is the first server to take a GPU, a graphics processor, and have it integrated on the silicon with the regular CPU, the Intel Xeon processor. Right next to it on the silicon is the accelerator, or the coprocessor called a GPU, a graphics processor. What does that do? That renders the acceleration of graphics and visualization extremely quickly. Second thing it does is it allows the vector processing of a GPU, regardless of graphics, right? The vector processing to be extremely fast. And that's how we were able to do this. We took this, and now we're working together with a customer. And as you can see, this is specifically 2 dual-core CPUs, a graphics controller, and this is an Intel product working with my partner, Intel. Any from Intel here? They're also, of course, an NI product. So a real-world example, and some of this is right here with the C-RIOs, is this machine condition monitoring and smart prognostics, and working with another partner called Spark Cognition that does predictive analytics to predict 2 Fs, failures, right? To predict a failure or a fault or something like that. Actually, not 2 Fs, a failure, faults, and then a third thing called threats. Security, as well, threats. That is not necessarily a failure or a fault. And this is another real-world example in which the analytics can actually happen very quickly at a low power. This I lifted, courtesy of National Instruments, from one of National Instruments' proposals to another large European manufacturer, and you'll notice it follows the 3-tier solution. It's just from the bottom up in the IT infrastructures. And I find this really fascinating. I'll give you a couple of details. If you look at place and time, this was part of my doctoral dissertation I did. I analyzed this notion of eliminated place and time. Now, I think you'd agree with me, the most efficient way to do any human activity, almost, there's some other things you can talk about, but almost any major human activity is to eliminate the dependency on place and time. Right now, we have not eliminated that at all. You are here at a location listening to me during a specific time, of which I'm running out of, I understand right now. Now, if you follow that notion, the telephone annihilated what? Not time, but it annihilated place. The ATM machine, the automatic teller machine, annihilated time, not place necessarily, right? So you look at all, you can map human activity, and I did my doctoral dissertation in telemedicine and healthcare. How could we eliminate you having to physically go to a doctor's office, a physician, when he would see you, when he was open, but still get health care with that, right? So let's do this in the world of IT, in the world of test and measurement. The highest quadrant of efficiency, we try to seek to move here, and together National Instruments and HP are annihilating place and time with the access to data to improve time to insight. That's a lot of buzzwords, right? All in once. And by the way, it's green. All right, that's a lot of buzzwords all in one. So the acquisition, the analysis, and the action of big data and the time to insight. Think about this program. Do you have it, Shazam? That predicts a song that you're listening to, right? So anyway, you play the song, the information goes up to the Amazon cloud, and then it comes back, right? So the acquisition is done in one location, the analysis in another location, very far away usually. Could be a data center in Europe, et cetera. So the highest quadrant of visibility, I want to move fast. The acquisition at this particular large manufacturer is part of the smart factory, but not the same customer. I'm trying to protect the anonymity of some of these customers here. The analysis is done at the edge and at corporate IT, but they want to extend it. So with my partner Citrix and the built-in graphics, I'm happy to announce here today, we are going to market with the National Instruments company. Yes, HP and National Instruments have partnered, and National Instruments is an ISV, formally signed up with HP. We are going to market it's the first step in our partnership, taking some National Instruments product called Diadem and Data Finder, which, as you know, are very IT-related technologies, but very important for the analysis of data and the visual insight you can get from data. And we are remoting it to scientists all over the world where the data is collected in one location. Why is that profound? Because if it's big, it's hard to transfer, right? And if it's hard to transfer, whether it be over even a T1 line or some sort of a line under the ocean or a satellite, it takes time. Sometimes days if it's really big data. Or you could what? You could send by courier or ship overnight a memory key or a hard drive. That's one way to ship. But again, that takes days, at least one day usually, right, as well. But what about the immediate, remember, time to insight, immediate insight into this business and this engineering? And we can do it by the analysis being taken place and then the action being taken place in other places around the world. It's an amazing concept without having to move the data. There's also security implications to not moving the data as well. How can we do this? With the very server my team has developed, by the way, in Singapore. I have a lab and a team there who have developed this. And this is because of the rise of the SoC, the system on a chip. And there's these devices that use the ARM server. I'm going to go quickly here because I'm running out of time and I want to keep you on the agenda because I don't want you to miss the next session called Big Analog Data by my colleague Andrea. Are you here? Well, maybe you're getting ready to do your big analog day. Anyway, so I would encourage you to go there. But let me move, and I want to end in a couple of things. What's kind of cool is we have this new Moonshot server that we produced at ARMTech, which is the first 64-bit ARM server. Right? Most servers are mainframes or they're Intel, as you know, Intel architecture. And I'm going to keep moving fast, but this is interesting. This 2D torus mesh has intrigued PayPal, a customer whose permission I got to use, because we can actually inter-processor communicate with fast data so they can get time to insight into their data. What do you think they're looking for if they're PayPal? They're looking for anomalies in the transaction, right? All the way from fraud to some sort of a mistake. And the sooner you find it, the time to insight, again, this is time to business insight. What can you do? You can take action to avoid catastrophe. This particular ARM server has 4 memory channels, and Sandia Labs has picked it up to do molecular dynamics, hydrodynamics. And what I find fascinating, this is an ARM server, and are you familiar with what's in the zinc product that is used in the SOM and in the Cerio? It's ARM technology, and I'm very interested to explore how these synergies can take place, because it relates to what David said about scaling up. So now we really, in some ways, David, we could take a fourth dimension after the NI products getting into the data center and the cloud with the same ARM architecture, and it'll be interesting to explore that as well. How did this get in here? Oh my goodness, one of our marketing guys put this award. We just won the Info World 2015 Technology Award for this particular server, so I threw that in simply to brag about it. Yes, it's very self-serving. I want to close with the instrumented athlete. This is American football. American football, there's something called a hit, right? A tackle. And when you get hit, and I grew up playing American football, and it's a really big thing when you can hit somebody really hard. And the business asset is the athlete, so it has to be monitored and instrumented, right? That's the asset. So when there's this hit, this idea of a hit, boom, boom, that's kind of exciting for at least men. I don't know the world of women, because I'm not one, although I am married to one and have a daughter. This is kind of cool for us, and it has something to do with testosterone, they tell me. But this hit is exciting. And I believe that this idea we could measure and call it the impact factor for sports. This is all predictive. It's not happening today, although I've spoken with a company who's interested in this. And this impact factor would then be, of course, analyzed by National Instruments equipment, taking this data analytics to the next level, bringing it up and broadcasting the hit. It goes up into the cloud, the impact factor at some level. And I believe someday, just like in soccer, the athlete would have a record of number of goals or number of defenses, in baseball, number of home runs, number of strikeouts as a pitcher. You get the picture. I believe in these contact sports, it'll be the impact factor. This athlete took the highest hit ever known to humankind. Contrariwise, this athlete gave the highest hit ever in the history of mankind. And I believe this will happen. It will be shot into your home, into the bars, and you will feel that impact factor in your Internet of Things device called the Easy Chair or your phone, and it will vibrate commensurate with the hit. I really believe this will happen. Let's see if it will. I don't know. Should I stop now, or do I have another minute? Somebody tell me. How bad off are we? Because David just talked forever, didn't he? What do you think I should do, Christian? You tell me. 60 seconds. All right, 60 seconds. A good company aggressively, I'm going to give you a tip here. When you hear one of my keynotes, you get more than just a commercial about NI and HP. A good company follows the trends, but a great company what? Sets them. And that's what I encourage us to do here. And I want to look at my view of setting trends with innovation. First of all, the opportunity to be different and get margin, make money for your company and for yourselves is higher if you have more innovation and differentiation. First of all, there's no innovation, and there are companies that can do that, such as my competitors. You heard that dig. They don't have any innovation, but they can sell and make money. Hamburger chains, fast food, not necessarily innovation, but they make money. It's a business, right? Another way is responsive innovation, where you know the customer wants it faster. Responsive innovation in NI would be they want more accuracy and a higher sample rate, right? That would be responsive. It's no secret the customer's asking for it, but it is innovative when you can do it. But here's where you can really do well, or what I call organic innovation. Now read that. You set the trend by predicting what the customer would buy before the customer does. I personally did this when I was pioneering blade servers. We'd never had a customer ask for it. We were insightful enough, using Bayesian reasoning, right, to discover what the customer wanted before they need it. Sometimes innovation is hard. Sometimes your company doesn't get it. This is you innovating, and your company is thinking, what? I spent most of my career trying to convince my company to do something it didn't understand, even when I was at NI. Trying to convince them to do something it never done before and didn't understand. And then lurking in the background in this tag team wrestling match are things like manufacturing and the development expense. Innovation is hard, but it is worth it. I'm out of time. Thank you for having me here. It's just been a pleasure to be in this great country, in this city.